Hey, hello everyone. In this session, let's study about typecasting. Typecasting is about changing a value of one type to a value of another type. So there are two types of typecasting: implicit typecasting and explicit typecastings. The implicit typecasting is also called automatic because the type conversion happens automatically. Let's see the example of implicit typecasting first. So this program consists of implicit typecasting here. Let's run these programs to see the output of this program. So this is the output of this program. So as you can see here, because 1 divided by 2 is 0.5, but 1 is int type and 2 is int type, int type divided by int type must result to the int type. So the output of line 8 is 0, not 0.5, because decimal points are truncated, not rounded up. Similar to line 8, line 9 also produce 0 because int var1 and int var2 is int types of variable. So this one is also 1 divided by 2, but because int type divided by int type must result int type, so this result to 0 as well. But some situation you might want the result to be more precise, like printing floating point values. So for that case, if you change 1 to 1.0 like this, the program will perform implicit conversions. For this case, the evaluation result will be implicitly, which means automatically change it to the floating point value because 1.0 is double types and 2 is int type. Double type divided by 2 must result to the double type. So the output of line 10 is 0.5. And for the same reason, line 11 is also produced 0.5 because 2.0 is a double types. So implicit conversion happens in line 10 and 11. But think about this. We can implicitly convert the type of evaluations of line 10 and 11 because they are literal constants. We just added the decimal point to this literal. Here we added 0.0 here, we added 0.0 here. But how can we convert the type of evaluation results on line 9? Can we add the decimal points to this variable? Let's see what happens if we add a decimal to the variable name. So here we added 0.0 decimal point to the int var1 variable. Let's see what happens if we compile this program. As you can see here, compiler throws error because this is not syntactically correct one. So here the explicit conversion comes. Let's go back to the slides and talk about the explicit conversions. So unlike implicit type conversion, which happens automatically, for the explicit type conversion, programmer has to explicitly specify the types to be converted. And there are 3 different ways to explicitly converting types. The first one is a C style or order form of casting. And second one is a C++ style typecasting. And the third way to convert type is using cast operator. So let's first look at the C style casting here. So since most of you have already learned C programming language in other class, you are probably familiar with this style of casting. The syntax of C style of casting, as you can see here, you specify type within brackets in front of the expressions. The results of these expressions will be converged to the specified type. We call this as a cast notation. So here, this is a cast notations. This expression is same as above expressions. The difference is that here the programmer explicitly specified cast notations. So 17 is int type originally, but due to this explicit type conversions, it changes to the double type. So the result of these expressions and the above expressions is same. They will both produce double type results. The only difference is that above is implicit type conversions, whereas below one is explicit type conversions. And typically we use explicit type conversion with variables because we just saw that we cannot implicitly convert if the expression is evaluated with variables. We cannot just add the decimal point to this variable name. So this C-style typecasting is still allowed and valid in C++. Your program will work as expected even you use such C-style casting, but someday this older form of typecasting may be deprecated, so it is recommended to use newer form of typecasting. We just saw this example. Okay, now let's look at the second way of typecasting. The second way is to convert type is using C++ style. It is very similar to C style. Let's see the example right away. So here 17 divided by 5.5, which is the same example expression we saw in previous slides. But here 17 is also explicitly converted into double type. But we are using different notations. In the previous slide, we used cast notation like this way. This is cast notations. But here, C++ style, we use a function notation. So this is function notations. And the syntax of function notation is that you specify the type here and put the expression within the round bracket. So its form is like calling a function. So we call this a function notation. Let's look at the example code. So if you look at this program, let's first compile this program and see the output. So this is the output of these programs. So if you look at here, this is a C style explicit conversions. It uses casting notations. This is also C style casting. And this is also C style, but the this one and this one is a C++ style of casting because it uses a function notation here. And this is a implicit typecasting example. So every line except the line 12 produce 0.5 because of the explicit type casting. So here 1 is converted into double and then divide by 2 with int type. So double type divided by 2 produce double type, so it produces 0.5. The other line also produces 0.5 with the same reasons, but uses a different style of casting. But line 12 produces the 0 because of these round brackets. Because of these round brackets, 1 divided by 2 evaluate first, which is int divided by int, which results to the 0, and the 0 value is converged to the double. So that is the reason why line 12 produced the 0 output. So we have looked at the C style casting and C++ typecasting. So this is how you use it. So let's go back to the slides. Now let's talk about the third way of explicit typecasting. The third way is using a typecasting operator. And there are 4 types of casting operator: the static cast and constant cast, reinterpret cast, and dynamic cast. The dynamic cast relates to the polymorphism, so we will study this in a later course. And similarly, we will talk about the reinterpret cast after learning class. So for today, we will look at the static and constant cast. The static cast is very similar to C style casting. This is a general purpose typecast. In most of the time, you will be using this static cast operator. So as I already explained you by using a demo code, we can easily convert types of literal by adding or removing decimal points like this. But we cannot do that with variable because adding decimal points to variable is just syntax error. We saw this in previous example by using a demo source code. So for that case, we use explicit casting. So this is how you use a static cast operator for the explicit type conversions. The syntax of static cast is shown here. You specify static cast keywords and put the type within the angle brackets and put the expressions in round brackets. We call this as a static cast because it is compile time cast. And because static cast is compile time cast, the compiler can check the correctness of the conversions. So this is one advantage of using static cast. So which means the compiler will check for you whether it is okay to convert one type to another given type. So it is much more safer than using a C style casting. Let's explore static cast with a demo code. Okay. So let's compile this program first. And run it. So there are 3 static cast conversion here. Line 12 produced 0.5 because int var1 is 1 and int var is 2. 1 divided by 2, but int var is statically cast to double type. So double divided by int results to the double type, so it's 0.5. Similarly, int var2 is explicitly converts to the double type using static cast operator. So this one also produced the 0.5. But for line 18, it produced 0 because of this round brackets. It first evaluate this expression, which is 1 divided by 2, the int type divided by 2, which leads to the 0. And by converting this 0 to double type, so line 18 produce a 0. So this is how you use a static cast operator. Let's see another example. Assume that there is a int variable, int var3, and character variable, char. And if you look at here, this is a explicit type conversions, but it uses a static cast operator, and this two line uses the C style typecasting. But here, int types of variables are converting to the character pointers, and here character variable is converting to the int pointers, and this is also same but using a C style character to int pointer, int to character pointer. Let's compile this code and see how the compiler produce output. So if you compile this code, as you can see that compiler throws arrow that static cast from int pointer to character pointer is not allowed. So here, int pointer to character pointer conversions is not allowed. It can be checked. Compiler think that converting integer pointer to character pointer is dangerous operations because integer pointer is 4 bytes, character pointer is 1 byte. So there is a data loss of 3 bytes, so which may lead to the unexpected behavior from the program. So compiler throws error message for you. But as you can see that C style of explicit conversions, if we use a C style of explicit conversion, compiler does not throw any error messages. So as I told you in the previous slides, static cast explicit conversion happens in compiler time. So compiler checks these conversions and throws error message if that conversion leads to some dangerous operations. So it is recommended to use a static cast conversion instead of C style of conversion. Is much safer, and you can get a help from the compiler. So let's go back to the slides. Okay, now let's study about constant cast. The constant cast is used to cast away the constants of reference and pointers. It cannot be used to remove constant modifier of other types of variables. So it can only apply to references and pointers. That's one thing you should remember when you are using a constant cast operator. If you learn C programming before, I am sure you know what pointer is, but if you don't know about it, don't worry, we will learn pointer and references type next week. But for now, let me briefly introduce you about reference type for understanding this constant cast. The reference type is introduced in C++, so there is no reference type in C programming language. We can declare the reference type variable using ampersand as shown here. So var2 is a reference types of variable because of this ampersand. You can think of reference variable as an alias, which is another name for an already existing variable. So here var2 is a reference type variable, and which means it is an alias of var1 variable. So if you change the value of var2, it affects var1 as well. So that's very brief explanation of reference variable. Going back to the const cast operator, the syntax of const cast is similar to static cast. You put the types within the angle brackets and the expression in round brackets, and you use a const cast keyword here. So this is how you use a const cast operator. So this statement here removes the constness of var2. var2 is a reference type with declared with a constant modifier. So with this line, var2's constants are removed. So and therefore using var3, you can change the value of var3, var2, and because var2 is a reference variable of var1, we can also change the value of var1 through var3. So let's study about const cast more about using example code. Okay, so there are 3 examples. Let's first look at the example 1. Let's first compile this program. Okay, so if we compile this program, let me fix this compiler. Okay, so if we compile this program, compiler throws error message like this one. So constant cast to double, which is not a reference or pointer to objects or pointer to data member. So as I explained you in previous slides, that constant cast can only be used for the reference and pointer types of variables. But because A is not a pointer or reference variable, it's just double types of variable. So compiler throws error message here. So be careful about this one. Now let's look at the example 2 code. Okay, now compile again and see how. Okay, so for this one, compiler error throws here. Cannot assign variable B with a constant qualifier type constant double. So compiler throws error message here because we did not remove the constants of the variable B. B is declared with constant modifier, so we cannot modify the value of B. So this line produces an error message. So if we use a constant cast operators and remove the constants of reference variable B by using this way and save it to the C. Now, if we modify C, we can update the value of B and A as well. Let's see. Let's compile this code and see the output. As you can see that now compiler does not throw error message. Here we remove the constants of variable B, and we can use constant cast because B is a reference types of variable. And because C is a reference type of variable of B, so if we update the C to 2.2, it also affects the B, and because it's also B is also reference type of A, it also affects the A as well. So if we change C, we can also change A, B, C. So that is the reason why the A, B, C is changed to 2.2. So this is how you use a const cast operator. Let's see the example 3. The example 3 source code is exactly same. The only difference is that the double A variable here, in example 2 code, there is no const modifier in double types of A variable, but in example 3 code, there is a const modifier in double types of A. So the code is same. Here we remove the constants of B, and we use a C reference type variable to update the value of B and A. Let's compile this code and see how program produce output. As you can see here, A is not modified, is 1.1. B is modified to 2.2, and C is modified to 2.2. So the output is different to the example 2 code and example 3 code, because example 3 code consists of undefined behaviors. So you must be aware of this one. To modify value, which is initially declared as constants, is undefined behaviors. So here in this example, C is reference types of variable of B, and B is a reference type variable of A. So A is an initially declared variable, but it is with a constant modifier. So modifying a value which is initially declared as constant is undefined behavior. So undefined behavior means that program's output is not guaranteed. So depending on the compiler's implementations, program's output may vary. So be aware of these cases. Okay, let's go back to the slides. Okay, so we just saw these examples. So in this lecture, we talk about the typecasting, the implicit typecasting and explicit typecastings. And there are 3 different ways for explicit typecasting: C style typecasting and C++ style typecastings, and the usage of typecasting operators. Okay, so that's it for this session. So see you next time.